I just want to review two brief definitions of what fractions and decimals are. A fraction is a point on the number line, so this would be a fraction. Let's say 4/5 would mean to take the segment from 0 to 1 and divide it into 5 equal pieces. 1, 2, 3, 4, 5. And then take the fourth copy of that. So this is 0/5, 1/5, 2/5, 3/5, and 4/5. So this is where 4/5 would be on the number line, a point on the number line. Okay, a decimal is a fraction whose denominator is a power of 10. So therefore, it's a fraction whose denominator is a power of 10. So it could be 10. This could also be a decimal, 1/100ths. The third power of 10 is 1,000, and I could keep on going on. Okay? Alright, the steps for changing a fraction to a decimal are as follows. We're going to follow the algorithm, and an algorithm is a step-by-step procedure to get an answer. Alright, the first step is to put the numerator inside the division house. So put the numerator inside the division house. Let's take, for example, the fraction 4/5. Alright, the numerator in 4/5 is 4, the denominator is 5. So we'll put the numerator of 4 in the division house, and the 5 will go outside the house. Step number 2 says to put a decimal point after the last digit inside the house. The last digit inside the house is 4, so put a decimal point to the right of that, and then also put it above in the quotient, directly above it. It's really important that you line these up. And then write as many zeros as you need to after that. You could write an arbitrary amount. Okay? Next, we're going to divide as usual until you get a remainder of 0. If you get a remainder of 0, the decimal is going to be terminating. And if you get a remainder that's not 0, you're going to keep on seeing a repeating block of subtraction, and that means it's a repeating decimal, and I'll show you how to notate that. Alright, let's divide as usual. 5 goes into 4, 0 times. 0 times 5 is 0. 4 minus 0, 4. Pull down the 0. 5 goes into 40, 8 times. 8 times 5 is 40. 40 subtract 40, 0. I got a remainder of 0, I can stop. This is what kind of decimal? A terminating decimal. So 4/5 is equal to 8/10. The way that you can check to see if this is actually correct is take 4/5, and if you say they're equal, 0.8 as a decimal fraction is written as 8. What number do you see? 8. And its denominator is a 1 with how many zeros to the right of the decimal point? 1. So it's 8/10. So this is 8/10 right there. If you want to check to see if they're actually correct, use the cross multiplication algorithm to compare fractions. 10 times 4 is 40, and this should be equal to the same product. 5 times 8 is 40 as well. If they check out, that means that you have the correct equivalent decimal for that fraction. Okay? Alright, let us keep on moving on. Let's represent the following fractions as decimals. If you want to take a moment, you can stop the video and try to do these problems right here, and when you're done you can click right back and we'll check to see if you got them correct. Alright, we're changing fractions to decimals, so I'm going to put the numerator on the inside, denominator on the outside. I'll do that for all of these. Numerator on the inside, denominator on the outside. Numerator on the inside, denominator on the outside. Numerator on the inside, denominator on the outside. Then I'll put a decimal point to the right, as well as in the quotient, and as many zeros as I would like or as I need. I'll do that. I'll put 3 zeros on them for now. I could put 4. It won't change the answer, because what I mean is I have 9 and nothing, and nothing, and nothing, and nothing. Okay? Alright, here we go. And then divide as normal. We're going to keep on going until we get a remainder of 0 or until we see a repeating block of subtraction. And what that means is like something like this. We'll see something where we're repeatedly seeing a subtraction. Repeated block of subtraction is happening. 10 minus 9. Okay? Alright, let's keep on going. Alright, 5 goes into 3, 0 times. 0 times 5, 0. 3 minus 0, 3. Pull down the 0. 5 goes into 30, 6 times. 6 times 5 is 30. 30 subtract 30, 0. I can stop because I got a remainder of 0, so 3/5 is equal to 6/10. We'll check these out at the end. Alright, next I have 3 goes into 1, 0 times. 0 times 3, 0. 1 minus 0, 1. Pull down the 0 to make 10. 3 goes into 10, 3 times. 3 times 3, 9. 10 subtract 9, 1. I don't have a remainder of 0, and I don't see there's a pattern yet. 10 minus 0, 10 minus 9. No pattern in the subtraction. Alright, 3 goes into 10, 3 times. 3 times 3, 9. 10 subtract 9, 1. I don't have a remainder of 0, but I notice that there's a repeating pattern of 10 minus 9 happening. Wherever that is happening, you're going to actually stop. And because we're going to keep on getting that 10 minus 9, you have to use a symbol and notation to let us know that that is actually repeating. So what we've done is we're going to write 0.3, and the 3 is going to keep on repeating, so we're going to stop it. And we're just going to say, this is the notation we use when we want to say that 3 is going to keep on repeating as a decimal. So it'll be 0.333333333333333333 forever. Forever. Okay? So it's you can almost think of that as like a broken record. That is what the repeating bar will stand for. 0.333333. Alright? Alright, let's go to the next one. I forgot to write the decimal point right up there. Alright, here we go. 8 goes into 9. 1 time. 1 times 8, 8. 9 subtract 8, 1. Pull down the 0. 8 goes into 10. 1 time. 1 times 8, 8. 10 subtract 8, 2. No repeating pattern in subtraction. Keep on going. 8 goes into 20. 2 times. 2 times 8, 16. 20 subtract 16, 4. Pull down the 0. Notice how carefully I'm doing my work. I'm lining everything up, pulling everything down, straight down. 8 goes into 40, 5 times. 5 times 8, 40. 40 subtract 40, 0. I can stop. The answer is 1 and 125 thousandths is the decimal equivalent to 9/8. Alright, and this last one, 9 goes into 8, 0 times. 0 times 9, 0. 8 subtract 0, 8. Pull down the 0. 9 goes into 8, 80, 8 times. 8 times 9, 72. 80 subtract 72, 8. No repeating pattern yet. Keep on pulling down. 9 goes into 80, 8 times. 8 times 9, 72. 80 subtract 72, 8. Okay, do I see the remainder of 0? No, but I do see another repeating pattern of subtraction, another repeating block of subtraction. So therefore I'm going to stop it right in its tracks, and I'm going to write it as 0.8 repeating. Okay? To check your terminating decimals to see if they're right, you can simply set the original fraction, 3/5, equal to the decimal fraction form of your decimal. So this is 6/10. And you can cross multiply, you'll get 30. Cross multiply, you'll get 30. They check out. This is correct.